How do I build a motorcycle frame seems to be a fairly common question for search engines. Obviously you'll need quite a wide skill set, but once you know the mechanics of it, that still presents the problem of how do you apply those skills. Again, this would seem to be a fairly common problem, as another favorite question for search engines is, where can I get plans for a frame? Traditionally you got plans for a frame by making the frame, measuring it, and then transferring those measurements to a drawing. These days the expectation is that everything can be designed on a computer, but the reality is that real-world vagaries and variations mean that the input is unreliable and the lovingly detailed and dimensioned drawing is often useless. This three-part series is intended as a guide to how I go about arriving at a physical frame that looks the way I want it to look. It does nothing to guarantee the structural integrity of the frame. I'm sure there are other ways, but this is the method I came up with and use. The three parts are going to be how it looks, how it works, and how to avoid killing anyone. This is part 1, and it's about how I make it look how I want it to look, without using any plans, and for the sake of simplicity, for now, I'm only going to look at rigid frames and pretend that rear suspension hasn't been invented. To build a motorcycle frame you need to be able to weld, able to fabricate sheet and plate steel, able to bend tube and able to machine parts. MIG welding is fine as long as you don't use flux core or gasless wire, as it presents too much opportunity for inclusions and hence weld failures. Use proper wire and proper gas. On the other hand, despite what you may have heard, TIG welding is not a magic wand. If you're welding two tubes with 1/8 of an inch wall thickness together and you have lovely looking 1/16 of an inch wide weld bead, you haven't got full penetration and it's almost certain to fall apart. Bending tube will require a tube bender, and that's an actual tube bender, not a hydraulic pipe kinker from Harbor Freight, Machine Mart or other national tool emporium of choice. It will also require some tube, and as a rule of thumb the tube should be the same material specification as whatever your national motorsport body prescribes for roll cages, and it definitely should not be water pipe. Sheet or plate fabrication isn't rocket science, especially if you have a pair of straight leg calipers. The mill scale needs to come off if you use hot rolled. In essence, a motorcycle frame is a bracket that you attach some forks, wheels, and an engine to. Having the forks, wheels and engine you intend to attach to the bracket means the bracket can be designed to fit them, which makes far more sense than making a bracket and randomly searching for parts that fit it. It also ensures that the parts will work together. If you use a steel-framed motorcycle as a parts donor, then usually most of the bits that need machining can be stolen off of the donor. If you're intending on riding the finished article, then a running donor with functioning brakes is a good idea, as if you start buying stuff like brakes and electrics as bits and pieces, it adds up really quickly. Take a look around. Buying used parts and assembling them into a motorcycle isn't a popular business model for a reason. I have a video on how I built my frame jig, and basically this section is about how I get the measurements to set the jig up to build the frame I want. At this point I have the engine with the carbs, the forks assembled with the front wheel, and the rear wheel and axle. Design decision number 1 is ground clearance. Typically I use somewhere around 5 inches under the engine sump. Local curb heights, potholes, and where exactly the exhausts are going to go are more important than the desire to look cool with a stupidly low motorcycle, because there's nothing cool about getting beached on a speed hump. This is often a topic of debate, and on the occasions when people haven't listened and have come back and complained, then, told you so, is about all that I have to say on the subject. It's important to bear in mind that the wider everything gets, the sooner it sticks into the ground when you lean the motorcycle into a bend. Bearing all that in mind, I set the engine up on a wooden block at the required height and then chock it up so it sits level. The next bit, setting the forks up, is a little tricky as they want to run away and they should be set at ride height. For the majority of forks on normal motorcycles, the ride height is about 1 inch off of fully extended. So looping a ratchet strap through the wheel and around the bottom yoke or tree lets me squeeze the forks down by the necessary 1 inch and stops them from rolling around. At this point I use a jack or axle stand along with a length of timber to prop the forks with a G-clamp on the timber and position them in front of the engine. The axle gets pushed through the rear wheel so that the axle will lean on another axle stand and the wheel gets placed behind the engine. At this point I can visualize the frame when I'm looking at the arrangement of parts in space. I usually grab an assistant and use a straight edge to gauge the line from the top of the steering head to the rear axle. Make sure that will leave room for the throttle cable or cables. The gas tank tap is going to clear. There's going to be enough room for the forks to turn lock to lock without hitting the gas tank and anything else that looks problematic. I also try and get some pics of the intended rider standing over the arrangement, and sitting on a stool or block at around the ride height based on what the straight edge from steering head to rear axle suggests might be the seat rail height. I'll mess about with things until I'm happy that that is what I'm looking for and nothing untoward is going on in the way of clearances. It's surprising what a difference moving something by as little as 1/4 of an inch can make. In one of the CB750 chopper frame videos, I redrew the plan and added measurements from a nominal bottom plane and a vertical plane set 1 inch ahead of the front lower corner of the steering head to set things on the jig. This time the approach involves taking some measurements off of the mock-up. Firstly, I make a visual check that everything is square with everything else and symmetrical around a center line, paying close attention to the forks being vertical viewed from the front. This is important because, as I said earlier, as little as 1/4 of an inch can make a difference, and I'm about to measure my mock-up to get the information I need to set the jig up. I already know the ground clearance under the engine, so that's dimension A. Dimension B is the axle height above ground. I measure this both sides of the wheel as a check that the wheel is upright. Dimension C is the height to the top of the back of the lower triple tree, as that tells me where the rear lower edge of the steering head will sit. Where possible, I measure this with the headstock fitted to the forks. Dimension D is the angle the steering head is sitting at, usually measured from the vertical, but not always. Dimension E is the distance from the top of the steering head to the axle, and dimension F is the distance from the axle to the center of the engine sprocket. And that's all it needs to capture the look of the frame I want to build to fit the parts I'm using. Just 6 dimensions. The difference between this and working from plans for the CB750 frame is that the measurements are relative to each other and not Cartesian coordinates. Having tidied everything away, I get the jig up on a table and level it left to right, and front to rear. After that, it's time for the steering head to go on the jig, so the steering head stick is adjusted to match dimension D, and in my case, dummy bearings machined to the bearing size for the steering head on the outside and to the size of the steering head stick on the inside. I prefer dummy bearings to cones, as the bearing seat isn't always central to the steering head and cones can sit on the part that isn't concentric. A donor motorcycle with a steel frame will usually have a steering head that can be cut off of the frame and cleaned up, a notable exception being the CB750, which has a steering head made up from pressings. In some instances, the frame number can be used along with the original documentation as the identity of the new frame. The laws on this will vary from country to country, and indeed with the age of the donor within a given country. Check your local laws and learn the difference between a VIN and a frame number, as in many cases they are legally distinct things and it pays to know which law you're breaking or not breaking. For the CB750 frame, I fiddled the steering head up and down the steering head stick to get a specific distance from the jig upright, but it's not necessary to do that here, as all the dimensions are self-referencing as opposed to using the upright of the jig as a reference. With the steering head stick set to the correct angle, the next thing I do is refer to dimension C. I'm going to be setting the engine on some 1-inch square box section on the jig top surface, as having it wobbling around 5 and a bit inches above the jig isn't helpful, so I deduct the inch from dimension A, and obviously if I was using 1 1/4 inch box section under the engine or 30 mm box, then I would deduct that amount from A. Dimension A, minus the thickness of the box section support under the engine, becomes dimension H for height, as it tells me how much heights from the mock-up are reduced by to get the height over the jig. Dimension C, the height of the steering head, gets dimension H deducted from it, and the rear lower corner of the steering head is set to that distance above the face of the jig. The next step is to set the axle plate holder at dimension B minus dimension H above the face of the jig. For now, I pay no attention to the distance the axle plates are separated by, I'm just concerned with setting the height of the front of the axle slot above the jig. Once I've set that to B minus H, I consult my notes and slide the axle plate fitting along the jig until the measurement from the top of the steering head to the center of the slot fixture is equal to dimension E from the original parts mock-up. Finally, I set the motor on the jig and slide it back and forth until the center of the front sprocket is F units from the center of the front pin of the axle plate fixture. At this point, if we call the bed of the jig the X-axis and the upright at the front of the jig the Y-axis, then all the important points are now located on those axes. It's possible to record this information and create a profile plan of the frame I'm building. The problem is that this isn't going to make a viable plan, as there's the Z-axis to consider, which is left to right across the jig. The steering head will be sitting in the correct position on the center line of the jig. What remains is to establish the Z-axis measurements for the engine and the axle plates, because as things stand this isn't going to make a viable frame, let alone a drawing. In the next video, I'll describe how to do that. In the meantime, take care of yourself and I'll see you in the next one. Well, not me, because I'm obviously a text-to-speech AI, but you get my point.